For 70 years, since its debut in 1952, the B-52 Stratofortress has been a steadfast asset for the U.S. military, consistently proving its reliability. Recently, the Air Force has reaffirmed its confidence in this iconic bomber by announcing a $2.6 billion investment to equip it with new engines. This surprising move has sent ripples through the aviation industry, as it indicates that these upgrades will keep the B-52 operational for at least another 30 years, pushing its service life beyond a century. But what exactly are these new engines, and what implications do they have for the aviation sector? To grasp the significance of the B-52's enduring role in the Air Force, we must revisit the reasons behind its original development. The Boeing B-52 Stratofortress has been a key part of U.S. military strategy since its first flight in 1952, developed to address Cold War tensions by providing a long-range strategic bomber capable of delivering nuclear weapons without relying on foreign bases. Initially conceptualized in 1946, the B-52 became a crucial element of the U.S. Air Force's Strategic Air Command, responsible for long-range bombing and nuclear deterrence. Its ability to carry heavy payloads and its extensive range made it ideal for this role, forming a critical component of the U.S. nuclear triad alongside intercontinental ballistic missiles and submarine-launched ballistic missiles, ensuring a credible deterrent against Soviet attacks. One of the key innovations of the B-52 was its ability to carry out long-range missions without requiring forward-deployed bases, which could be vulnerable to attack. At a time when overseas military bases were a strategic concern due to their proximity to potential adversaries, the B-52 provided a solution by allowing the U.S. to strike targets from bases within the continental United States. Its massive fuel capacity and in-flight refueling capability enabled it to stay airborne for extended periods, giving it the ability to fly intercontinental missions. This capability was demonstrated early in its career when the B-52 completed a 1957 nonstop around-the-world flight in 45 hours, further solidifying its role as a global strategic bomber. The B-52's role expanded significantly beyond its original nuclear deterrence mission. Although designed primarily for high-altitude nuclear bombing, it quickly adapted to new roles, including conventional bombing, electronic warfare, and reconnaissance. During the Vietnam War, the B-52 played a pivotal role in Operation Rolling Thunder and Operation Linebacker II, where it was used to deliver heavy conventional bomb loads over North Vietnam. Its ability to carry up to 70,000 pounds of bombs made it a crucial asset for carpet bombing campaigns, earning it a reputation as a fearsome conventional bomber. The aircraft's involvement in these operations demonstrated its versatility, transitioning from a Cold War nuclear deterrent to a tactical bomber used in conventional warfare. The B-52's capacity to adapt to changing warfare requirements ensured its continued relevance during major conflicts throughout the late 20th and early 21st centuries. It participated in the Persian Gulf War, Operation Desert Storm, in 1991, where it launched precision-guided cruise missiles and conducted conventional bombing raids over Iraq. The B-52's ability to loiter for extended periods and deliver precision strikes proved vital during the campaign. In the years following Desert Storm, the B-52 supported various missions in the Balkans, Afghanistan, and Iraq, providing close air support and conducting strategic bombing missions. It has continued to play an active role in the global war on terror, striking targets in Afghanistan, Iraq, Syria, and other regions where U.S. military operations are ongoing. One of the reasons the B-52 has remained in service for so long is its adaptability to technological upgrades. Over the decades, it has undergone numerous modernization programs, including enhancements to its avionics, radar systems, electronic warfare capabilities, and weapon systems. These upgrades have allowed the B-52 to remain a formidable force in modern combat scenarios. Notably, the introduction of new digital communication systems, such as the Combat Network Communications technology, and upgrades to its weapon suite, including the ability to carry precision-guided munitions and air-launched cruise missiles, have extended its operational life and kept it competitive with more modern aircraft. Despite newer bombers being introduced, such as the B-1 Lancer and the B-2 Spirit, the B-52 has outlasted many of its intended replacements. Its robustness, large payload capacity, low operating costs, and ability to absorb continual upgrades have kept it in service long past its expected retirement. Its current variant, the B-52H, is still in active duty, with plans for it to remain operational until at least 2060, over a century after its first flight. This longevity makes the B-52 a unique aircraft in aviation history, as it has adapted to meet the evolving needs of modern warfare while maintaining its core strengths of range, flexibility, and firepower. However, despite its remarkable longevity and adaptability, the B-52 Stratofortress faces significant challenges with its outdated Pratt & Whitney TF-33 P3 turbofan engines, which have been in service since the aircraft's introduction in the early 1960s. These engines, though reliable, are now significantly outdated and have become increasingly costly to maintain. The TF-33 engines are derived from the JT-3D engines that powered early Boeing 707 commercial jets, and while they were state-of-the-art in their time, the demands of modern warfare, fuel efficiency, and operational costs have outpaced their capabilities. Each TF-33 engine requires a complete overhaul every 6,000 flight hours, with a cost of approximately $2 million per engine. This high maintenance burden, coupled with the engine's inefficient fuel consumption, has contributed to the B-52 being one of the most expensive aircraft in the U.S. Air Force to operate, costing an estimated $70,000 per flight hour. Additionally, the TF-33 engines do not meet modern standards for noise reduction and emissions, further incentivizing the Air Force to pursue a new engine solution. To address these issues, the U.S. Air Force launched the B-52 Commercial Engine Replacement Program in 2018, with the goal of selecting new engines that would enhance the bomber's performance, lower operating costs, and ensure the aircraft's viability through at least 2060. After a competitive bidding process that included major engine manufacturers such as General Electric and Pratt & Whitney, Rolls-Royce emerged as the winner of the $500.8 million contract in 2021. Rolls-Royce's F-130 engine was chosen as the replacement for the TF-33 engines, marking a significant milestone in the modernization of the B-52 fleet. The Rolls-Royce F-130 engine, part of the BR-700 family, is a proven design with a long history of reliable performance in both military and civilian aviation. Variants of the F-130 engine power aircraft such as the Gulfstream G550 and Bombardier Global Express business size, as well as the Boeing 717. The F-130 has accumulated more than 30 million flight hours across various platforms, highlighting its reliability and durability. The F-130 engines are known for their fuel efficiency, low maintenance costs, and ability to perform well in demanding environments, key factors that make them an ideal fit for the B-52's modernization. One of the most significant advantages of the F-130 engine is its 30% improvement in fuel efficiency compared to the older TF-33 engines. This improvement is critical for long-range missions as it will allow the B-52 to operate with greater range and loiter time, reducing the need for frequent aerial refueling and increasing mission flexibility. Enhanced fuel efficiency will also reduce the overall operational costs of the B-52 fleet, which is especially important given the bomber's extensive use in global operations. In addition to fuel savings, the F-130 engines will help lower carbon emissions, making the B-52 more environmentally compliant in accordance with modern aviation standards. The F-130 engines also bring significant reductions in noise and improved environmental performance, which will help the B-52 comply with stricter noise regulations that have been introduced since the aircraft's original engines were designed. This will be particularly beneficial for the B-52's operations in areas where noise restrictions are in place, such as when flying over populated regions or during training exercises near civilian areas. The reduced noise signature also has tactical advantages, potentially making the B-52 more difficult to detect by enemy forces during missions. Maintenance and logistics will see a substantial improvement with the F-130 engines. The TF-33 engines, as previously mentioned, require frequent and expensive overhauls, which have become a significant burden on the U.S. Air Force's budget and manpower. The F-130, in contrast, is designed for long periods of operation between maintenance cycles, which will greatly reduce the logistical footprint required to keep the B-52 fleet operational. Rolls-Royce has stated that the F-130 engines will be able to operate for the remainder of the B-52's service life with minimal intervention, a critical factor given the Air Force's plans to keep the aircraft in service through at least 2060. The modernization program includes more than just the engines themselves. The B-52 will receive new engine nacelles, which are the aerodynamic twin pods that house the engines, to accommodate the new F-130 engines. Each nacelle will hold two engines similar to the current configuration, and the nacelles will be designed to improve the aircraft's aerodynamic efficiency and reduce drag. Additionally, New pylons will be fitted to attach the nacelles to the wings, further enhancing the aircraft's structural performance and ensuring the smooth integration of the new engines. This integration process will be overseen by Boeing, which is responsible for the overall modernization of the B-52 fleet. The F-130 engines are expected to extend the service life of the B-52 by at least 30 more years, effectively allowing the aircraft to continue flying until the 2060s. With this engine upgrade, the B-52 could become one of the longest-serving military aircraft in history, potentially marking over 100 years of service since its first flight in 1952. This longevity is unprecedented for a military aircraft, and it underscores the B-52's remarkable adaptability and enduring utility in modern warfare. Production of the F-130 engines will take place in the United States at Rolls-Royce's facility in Indianapolis, which has recently undergone over $1 billion in investments for modernization and expansion. This domestic production capability ensures that the engines and their parts will be readily available for the U.S. Air Force, further reducing supply chain risks and supporting American manufacturing jobs. Now, given Rolls-Royce's expertise in creating powerful engines, you might wonder why the B-52 isn't being re-engineered to use just 4 engines instead of the traditional 8. The choice to keep the 8-engine setup, even with the new Rolls-Royce F-130 engines, is based on several practical and engineering factors. These include preserving the aircraft's structural integrity without needing extensive redesigns, maintaining redundancy and safety with balanced thrust distribution, simplifying maintenance and logistics by continuing to use existing infrastructure, and retaining the historically effective design. This strategy allows the Air Force to improve the B-52's performance and efficiency with the new engines while avoiding the complexities and costs of a major reconfiguration. Rolls-Royce has initiated testing of the new F-130 engines, marking a significant milestone in the B-52's modernization program. The first re-engined B-52 are expected to be delivered by the end of 2025, with the entire fleet projected to be re-engined by 2035. This engine replacement is crucial to ensuring the long-term viability of the B-52, as the current TF-33 engines have become increasingly inefficient and expensive to maintain. Once fully upgraded, the B-52 will greatly enhance the U.S. Air Force's global power projection capabilities. The new engines will allow the aircraft to undertake long-range strategic missions with improved fuel efficiency, greater range, and increased flexibility. This modernization will enable the B-52 to remain a key asset in the Air Force's arsenal, capable of meeting the demands of modern warfare with enhanced performance and cost effectiveness.